Hi, and welcome to Vicor. It is easy to see that Vicor is different from any other company in the industry from start to finish, as we have completely revolutionized the fertilizer industry in relation to turf management. It is sometimes hard to communicate the differences in our program using our innovative Actimizers. One of the reasons for this is that we are constantly opening up new benefit areas and cost savings with our programs that were simply unheard of in the past. Another reason for this is that many people try to compare our program with what they have done in the past or what they currently understand. In a way, it's almost like comparing a tricycle to a modern-day jet, or a fire pit to an electric oven. There are so many advantages that trying to explain it to someone who hasn't experienced it is quite difficult. Having said that, I have no doubt we can help you become more profitable and efficient. And I'd like to take a little bit of time and talk to you about our innovative Actimizers. So what makes our Actimizers so unique? We start out with our three foundation products: Thatchback, Carbonade, Green Tree. Because they are low in pH, we could say they are energized, and because of the amount of carbon we have in them that we have registered through the USDA BioPreferred program, we can call them energized carbon. It doesn't do me a whole lot of good to talk to you about our products unless we understand what we're trying to fix. Salt. Where does it come from? Water is the #1 used resource on your course. True? How do salts affect irrigation water? Salts. How do salts get to the ocean? Do salts float? Would you use ocean water for irrigation water? pH of ocean water is 8.1, generally speaking. Where's the source water for the Great Salt Lake? The Great Salt Lake, similar to an ocean, has no outlet. So it gets all of its water from tributaries, headwaters. And if we go back and we can understand that after a rainstorm or snow melt, that nutrients are released, and that's what turns our rivers and streams dirty. At the end of those is an accumulation of salts. Do you agree with that? Salt. Salt is a mineral substance composed primarily of sodium chloride, a chemical compound belonging to the larger class of ionic salts. Salt, in its natural form as a crystalline mineral, is known as rock salt or halite. Salt is one of the oldest and most ubiquitous of food seasonings, and salting is an important method of food preservation. Salt is used as a preservative because it stalls the growth of bacteria, which when in contact with food causes it to spoil. The salt absorbs moisture through the wall of the cells, resulting in the death of bacteria, thus preserving food for longer. So if you have biologicals in your turf or soil, can you use salt as a fungicide? Because fungicides essentially control biologicals. Do we need salt? Absolutely. But in moderation. Salt is an essential nutrient. Too much of a good thing is not always good. And salt does have many uses. Is there a difference between salt and alkali? Here's a couple of definitions. Alkali. In chemistry, an alkali is a basic, ionic salt of an alkali metal or alkaline earth metal chemical element. An alkali also can be defined as a base that dissolves in water. A solution of soluble base has a pH greater than 7.0. Here's another definition of alkali. A soluble salt obtained from the ashes of plants and consisting largely of potassium or sodium carbonate. A soluble salt or a mixture of soluble salts present in some soils of arid regions in quantity are detrimental to agriculture. So essentially what that's saying is if you are applying anything that has a pH greater than 7, it could be detrimental to agriculture according to these definitions. Salts or alkali are all around us. Here's the Eagle River in Colorado. Is this river preserved or nutrient rich? You can see the salt or alkali accumulation on the rocks. If the pH is over 7, can we conclude that it is alkaline, brine water, or salt water? Is this a great source of irrigation water? It does come from the headwaters of the Colorado. Salts come in many different forms and sources, but what determines if a salt is good or bad? There's a couple pictures here that talk about organic fertilizer. Sometimes we can measure this by doing a compost test. In the lower right hand corner you'll notice some goose droppings. Are our soils lacking in a nutrient? Are those nutrients unavailable? What truly goes on in those areas? Here's a bag of Epsom salt, magnesium sulfate, a soaking aid for minor sprains and bruises, a saline laxative for the short-term relief of constipation, a plant nutrient for vigorous lawns, flowers, plants, vegetables, and trees. Is this a salt or a nutrient? Magnesium sulfate, 1 part magnesium, 1 part sulfur, 4 parts oxygen. What does the work? How about calcium sulfate? 1 part calcium, 1 part sulfur, 4 parts oxygen. Where is the energy and what is being left behind? Can we test for salts? Absolutely. There are many times we pull a plug and we see layering. Measuring of salts. We have an EC meter. EC is electrical conductivity. Why do salts create electricity? Do they have positive and negative charges? Can these also be nutrients? Here are some soil and water sample reports. If we look at the pH of the soil, it's 7.6, 7.7. Is that an alkali? Remember, anything over than a 7.0 is salt or alkali. How about our water? The pH of the water is 8.86. Alkali, brine water, salt water. What was the pH of ocean water again? What about the hardness? If we look at the hardness in parts per million, it's 175.96 parts per million, or 10.29 grains per gallon. We call water hard if it contains a lot of calcium, magnesium, or other minerals. Groundwater acquires these metals by dissolving them from the surrounding soil and rock. Essentially, if we have spring runoff, is that a way that groundwater picks up metals and distributes them to the ocean or Great Salt Lake? Once again, do salts float? Industry measures water hardness in terms of grains per gallon, or GPG, or milligrams per liter. A grain is defined as 64.8 milligrams of calcium carbonate. If your water tests at 1 GPG or less, then you have soft water. Water around 1 to 3.5 GPG occupies a gray zone between soft and slightly hard water. 3 to 5.7 GPG is moderately hard. Hard water is around 7 to 10.5 GPG, and very hard water is above that. If we go back to the slide where it talks about water and we go to hardness, the grains per gallon on that was 10.29. So can we conclude that that was hard water? Wouldn't it be nice to hook a Brita water filter to that and soften our water? Where is the pH of your soils or water? Salinity is the measure of soluble salts dissolved in soil or water. Saline soil has higher content of soluble salts. Alkali soil is a type of soil having high concentration of sodium. Alkali is related to high pH, greater than 7.3. So does pH play a factor? If 7 is neutral, if it's a higher pH, is that alkaline? Is that a salt? How about below 7? Is that acidic? Acid rain? The EPA says it's 5.0 to 5.5 would be rainwater. Would that be considered a nutrient? Back to our soil and water samples again. If we look at our exchangeable cations, they're measuring calcium, magnesium, potassium, and sodium. If we look at our water, are they not measuring the same nutrients? Calcium, magnesium, potassium, sodium, iron? Absolutely. What is the pH of our water again? 8.86. What's the pH of our soil? 7.6, 7.7. So can we conclude that these are both alkaline or salt? TDS is 467 parts per million, and this is going off of our water slide, or 105 acre inch. There's 152,000 gallons in 1 acre inch of water. So for example, for 500 gallons of water, you apply 1,900 pounds of TDS. If you water 7 consecutive nights at 500,000 gallons of water, you add 7 times 1952 equals 13,664 pounds of TDS, or approximately 6 tons of TDS. If you water 6 months, 180 nights, of 500,000 gallons a night of the same water, you add 180 days times 1952 equals 351,360 pounds, or almost 175 tons of TDS. How about over 20 to 25 years? And we wonder why greens fail after 20 to 25 years. Could it be the amount of TDS we're applying through our water? How about sodium? On this test we show 16 pounds added per acre inch of water. Again, 500,000 gallon cycle of water, 16 pounds times 27,152 gallons of water equals 295 pounds of sodium. 295 pounds of sodium. 7 days times 295, 2,000 pounds of sodium, 6 months, or 180 nights of watering, 500,000 gallons a night, 53,000 pounds of sodium added, or approximately 27 tons of sodium. Now who would ever thought of going out with a spreader and applying sodium? We don't think like that. But we never take 5 minutes to look at our water. Can we break this down? What about calcium, magnesium? We all add with a spreader per salesman or agronomist request. Why not make the calcium available in the water? And for those of you that say we have good water, wow, that's awesome. Want to figure the amount of TDS you are using? This slide shows some simple calculations. You can add your numbers in the appropriate slots. You can also convert from gallons to acres or per 1,000 square feet. Here we have the Western Fertilizer Handbook, and I pulled some definitions out of it so we could read through them. Chloride is found in all natural waters. In high concentrations, it is toxic to some plants. All common chlorides are soluble and contribute to the total salt content or salinity of soils. The chloride content must be determined to evaluate irrigation water properly. Are we doing that today? Are we looking at chloride? How does chloride differ from chlorine? Is chlorine not bleach? Do we use bleach wipes to wipe off our countertops to clean the biologicals or bacteria on it to keep us safe and healthy? Why is sulfate a problem? Sulfate, SO4, is abundant in nature. Sodium, magnesium, and potassium sulfates are readily soluble. Calcium sulfate, such as gypsum, has limited solubility. Sulfate has no characteristic action on soil except to contribute to the total salt content. So if we look in the left-hand corner, calcium sulfate, such as gypsum, there's a pile of it. How does that pile of gypsum differ from the products that you run through your fertilizer spreader? In the previous slide, we talked about sulfate. This slide talks about black layer formation. And I'm not going to spend a whole lot of time talking about it. You're more than welcome to read through this at your leisure. But if you read through this, you'll notice they're talking about aerobic biologicals, or the absence of oxygen that contributes to black layering. And it's also a high sulfur concentration. So with that being said, can we conclude, according to this article, that black layer is an accumulation of sulfates that have created an anaerobic environment? The absence of oxygen is termed anaerobisis and is necessary for sulfide to form. So how do you get rid of black layer? Add oxygen. Is it truly that simple? What if we just stopped adding sulfur? There's a thought. What is the difference between a salt and a nutrient? Availability? Toxicity? Most soil samples are referred to as a nutrient availability, whereas water has a salt content. Why is that? What is the pH of ocean water? What is the pH of alkaline soils? If you are adding a high TDS water to the turf, it is only a matter of time before the soil takes on the same characteristics of the water. Magnets are a great example of energy, and opposites attract. If you are adding the same ion water to the soil, how do you expect infiltration to happen? It is only a matter of time before it starts to repel. There is energy with a magnet. Energy. For years, superintendents have been applying sulfuric acid to increase energy or release nutrients in the turf. Is SO4 an acid? That's sulfuric acid. That's battery acid. So if we look at a battery, low pH is high energy. If your pH starts to raise or get to neutral, you have no energy. How do you recharge your battery? You find a power source and you plug it in. Why is rainwater important, and why do we generally see a flush of growth afterwards? If we go to the bottom of the page, we can see the pH of pure water is 7. However, there are always impurities in rainwater because it stays in the equilibrium with carbon dioxide in the atmosphere. Carbon dioxide is weakly acidic, so it causes rainwater to be naturally acidic as well. I'll read that again. Carbon dioxide is weakly acidic, so it causes rainwater to be naturally acidic as well. Is this kind of like charging the battery? This leads to a calculation of a pH around 5.7 for rainwater, according to Harvard University. They should know what they're talking about. 5.7 is on the downside or the acidic side of the pH scale. Can we calculate that there is energy there? In addition to carbon dioxide, there are other acids in the atmosphere, such as sulfuric acid, resulting from emissions from the biosphere and volcanoes, and nitric acid from fires and lightning. What is the pH? Does it release nutrients? How much energy is in rainwater? Here's an electrical storm. Is there energy here? How valuable, when you go out and irrigate with a ½ inch of your irrigation water, how valuable is that? Do you see a result when you have a rainstorm come through with very little lightning? Let's say a ½ inch of rain. You see a flush of growth. How about with a 1/10 of an inch of rain and a lot of lightning? Do you see a flush of growth after that? So was it the water or the energy that created the flush of growth? Once again, what does rainwater have in it to make it great? Energy? What if we stopped reacting to the reaction and start reacting to the problem? Thatchback has a pH of 2.6, and because we are registered through the USDA BioPreferred program that measures carbon, can we say this is a carbon acid? Applied directly to the turf, increased turf turgidity, has an aerobic biological package. Superintendents have seen better root growth. Here are some other areas thatchback can be applied. Apply to a new sod area. Spray on new seed for germination. Urine spots. LDS. Why not just use it when you're hand watering? Carbonade is a great product. It is also registered through the USDA BioPreferred program. Has a pH of 0.7. So once again, this is an energized carbon or a carbon acid. It's designed to be injected through the irrigation system, and you should always add to your spray tank to adjust the water. There are many uses for carbonade. One of them is to eliminate the need for wetting agents. Why not adjust your water and add it with your herbicide, insecticide? Spray it foliar on trees. It is loaded with dissolved oxygen. Here's another great atomizer product, Green Tree. Superintendents are great at growing turf, but sometimes don't have the time to take a look at the trees. Another, carbon acid, low pH. Apply the product directly to the trunk of the tree and it'll move up and down in the cambium layer to increase root growth and tree health. It is arborist approved, and it's the only product that I've found to eliminate needle cast. I hope that you use this product and see the benefits that I have. Green Tree also has a biological package specifically for trees. It's also loaded with dissolved oxygen. Here are some other benefits. It's cost efficient. Use it with new plantings. How about when you're transplanting? It's designed to increase roots and health of the tree. Don't be fooled by those that claim high carbon. Ask for the BioPreferred label. And remember that we are using energized carbon. Energy with carbon. Low pH, high carbon. Ask for the USDA BioPreferred label. This slide correlates with the previous slide. Here we have the products from the BioPreferred website. Thatchback, Carbonade, Green Tree. You can pull all this information from the BioPreferred website. So when people ask for labels, here you go. In summary, remember that if you are using a high pH water, chances are it has high salt or alkali content. Anything over a 7 pH is considered alkali. If a lab uses an acid to extract nutrients or salts for your reports and you are not using the same acid, how do you expect to get the same results? You know what rainwater will do for your turf. Don't chase NPK if you can get more benefit from rainwater. How much NPK is available in your water if you could just make it available? Don't be afraid of an acid if it's a carbon acid. Please follow me on Twitter, and here's a link to my website. Thank you very much for your time.